Okay, so number 23, a steel ball is shot from a slingshot from a cliff that's 30 meters high. So that's what I've got going on here. This would be like our cliff that's 30 meters high. It stands 120 meters, or sorry, lands 120 meters from the base of the cliff. So really, it should be 120 meters from where this ball was launched from, right? If it's the base of the cliff, we don't really know necessarily where we're launching the ball from in relation to the base of the cliff, but it should say 120 meters from where it was launched. All right, so that's what's going on here. How long does it take to hit the ground? Well, we know that our time is dependent upon how high up, or the distance in the y direction the ball is. So we can use that 30 meters to help us out there, and we know that that's going to be dependent on something in the y direction. The two equations that I have for the y direction, there and there. This equation, though, remember that doesn't have anything to do with distance, so I can't really use that. This one does, so distance in the y direction. I know I'm good to go with that one. All right, so d equals v naught t plus 1/2 gt squared. D is coming from my distance in the y direction. My initial velocity, I can assume it is 0. Yes, there is an initial velocity in this direction, but that does not mean that there's an initial velocity in the up and down direction. I'm probably firing this thing pretty fast in order to get it to go 120 meters, but I'm firing it fast in the x direction. Again, not the y direction. So remember, we have to break it up into components of x and y direction. So it's 0 meters per second in the y direction, or the y component, and not in the x. I don't know my time, but 0 times time is going to be 0 anyway. 0 times anything, including a variable, is 0. Plus 1/2 times negative 9.8 t squared. So 1/2 of negative 9.8 is 4.9. When I do 30 divided by that 4.9, I get 6.12. Take the square root of that in order to get the time of 2.47 seconds. So that means that this 2.47 seconds is going to be for both the vertical and horizontal components. Because remember, if I'm firing a projectile this way, the moment in time that it hits the ground, or hits the water, or hits whatever's going on here, it is the time that it landed. The time is that it landed. Doesn't matter that it's up and down versus left to right. Because think about it. If I've got one object, that object can't land at a different time vertically and a different time horizontally. It's one object. How can it possibly have two different times? So this time is going to help us out with anything in the y direction and anything in the x direction if I'm asked for it. So part B, what's the horizontal velocity right before hitting the ground? Well, right there, I'm going to have to use my my time there. So I can, in dealing with a horizontal velocity, and the only formula that I have for horizontal is dx equals vt, or vxt. We sometimes see it written as. I know my distance. It's 120. That's what I can insert right there. I don't know my velocity. That's what I'm being asked for, but I do know my time. My time is 2.47 seconds. And then I have 120 divided by 2.47 will give me 48.6. Or if I just use the old way of writing the formula, v equals d over t. Well, my distance is 120. My time is 2.47. So again, I'm still going to end up doing 120 divided by 2.47 and getting 48.6 meters per second. So two ways that we can do that problem. First way here, second way over here. All right. And I know that this 48.6 meters per second, that's not only the time, or the velocity in the horizontal direction right before hitting my final target, it's also my velocity in the horizontal direction everywhere along the path of this projectile. Because again, nothing is pulling it back in the horizontal direction or pushing it forward after it's initially been thrust forward. In the horizontal direction, whatever the velocity is to begin with, that is the velocity throughout the trip. Part C, what's the vertical velocity right before hitting the ground? Vertical velocity, I've never ridden that roller coaster. It just seems like it would be something that would make me puke. Anyway, right before hitting the ground, we want to know what the vertical velocity is. So a couple ways that we can do that. Really only one way that we can do it. There's two different ways that we could rearrange the formula. This was kind of more of an old way that we wrote that formula, or the way that we've been using in this unit is v minus v naught equals at. Now how the heck do I know to use this formula in the first place? Well, I know that I'm looking for a vertical velocity right before hitting the ground. So right before hitting the ground, that would tell me that I'm looking for a v final or v, right? So again, v without the little naught next to it means that it is v final. So I know that I'm looking for a v final. This formula has a v, but it's a v initial. So I can't really use that, which means that formula is out of the question. This formula has a v. It's only a v initial as well, but at the same time, it's also in the x direction. So I can't use something that we're talking about in the x direction. So that leaves me with one formula there. My only option is that one, v minus v naught equals at, or my acceleration formula. So I don't know my final velocity. I know my initial velocity is 0 in the vertical, right? Because I might have a velocity of 48.6 meters per second in the horizontal direction, but that doesn't mean that I've got that same velocity in the vertical direction. In fact, I'm not going down at all to begin with, so that's why I have this initial velocity of 0 in the y direction. Equals at. A is negative 9.8 meters per second squared. We're getting that from gravity, and we solved before and said that the ball is going to take 2.47 seconds to hit the ground, so that's what I'm inserting over here, the 2.47 seconds. Multiply those guys together and I get negative 24.2 meters per second. The negative makes perfect sense since I am going in the downwards direction. Alright, moving on to number 24. So a projectile is shot horizontally from a cliff at 15 meters per second. It lands 25 meters from the base of the cliff. How long does it take to hit the ground? Alright, so a little bit of a different story here because I don't know my distance to begin with in the y direction. If I did, that'd be nice. I could just plug it into my distance formula and get the time. But I do know a couple of other things here. Right? I know how far it goes, how far this projectile travels. And I also know the initial horizontal speed that it was launched at, and I know that that's going to stay the same. So I'm actually starting in the horizontal direction this time, since I know a whole bunch of stuff in the horizontal direction here, horizontal direction there. Well, that leads me to use dx equals vt, because it's distance in the x direction, which I'm dealing with. And I've got my velocity in the x direction over here. Okay. And I can figure out what my time is then. So 25 meters for my distance, 15 meters per second for my velocity, divide 25 divided by 15, gives me 1.67 seconds. So that means it's going to take 1.67 seconds to fall this way. Remember, it's actually going in this arc fashion, so it's going to take 1.67 seconds to also travel in the horizontal direction, because again, one object, when it hits the ground right there, can't possibly hit the ground at two separate times, one for the vertical and one for the horizontal. Whatever time it hit the ground at is whatever time it hit the ground at, 1.67 seconds. How tall is the cliff? Well, now I'm going in reverse. I'm looking for my distance in the y direction. I know my initial velocity in the y direction is going to be 0, right? Because my initial velocity is only in the x direction that it's traveling, not in the y direction. My time, I just solved for, but it's going to be 0 times time anyway, so really we don't even need this part of the formula. You could leave it out if you wanted to. If it freaks you out, just keep it in and let your math do the work for you. 1/2 times negative 9.8, it's going to give me negative 4.9 anyway. We already know that from a bunch of these problems now. And then t squared is 1.67 squared. Again, the squared is only for this part of the formula. Only this part, like just this part. Don't square both of these. Some people are still doing that, so just watch out. Alright, so I end up with 1.67 squared times 4.9, because that's what this will be. Gives me 13.6. 0 plus 13.6 keeps it at 13.6 meters. Now, if we did come out with a negative, if you left this as negative, just realize that it's falling 13.6 meters, so that's why you might come out with a negative 13.6, but it's asking how tall is the cliff. We wouldn't say, oh, that cliff is negative 13.6 meters. We'd say, oh, the cliff's 13.6 meters if we were talking about this cliff. Sounds like fun. C, what's the vertical velocity right before hitting the ground? So we know if we're dealing with vertical velocity, so velocity in the up and down direction, I can only deal with formulas that have to do with the y direction. Well, I know this formula has to do with the y direction because it has acceleration in it. Or if we thought of that as it has gravity in it, that's fine too. The other formula that has velocity in it would be our v equals d over t. But remember, this doesn't have anything to do with acceleration, so if we're talking vertical, we can't deal with this formula because it has nothing to do with acceleration or gravity. So v minus v naught equals at. It is. We don't know our final velocity. We know our initial velocity is 0 in the y component, right? It's 15 meters per second in the x component, but this is not for the x component. This is for the y. So it's 0 meters per second for the y component. Negative 9.8 is, of course, from gravity. 1.67 seconds we solved before. That's where that's coming from. And so we are left with a little bit of multiplication here. So we're at negative 9.8 times 1.67 gives me negative 16.37 meters per second. The negative here does make sense because I'm going in the vertical direction. So right before hitting the ground, I would be falling in the vertical direction, so I would have a negative velocity, meaning down. All right, last one. Projectile is shot horizontally from a cliff at 15 meters per second. It takes 1.93 seconds to hit the ground. So we're going this way, and 1.93 seconds later, I'm right there. I'm on the ground. How tall is the cliff? So if this is our cliff here, we want to know, well, how high up is this thing? Remember, I know how tall something is if I know the time, because time's dependent on the height. Right? Because gravity is the thing that's going to be pulling this down. Gravity only acts in the y direction. So that's why I know to use this dy equals v naught t plus 1/2 at squared. The other thing the other formula that has distance in it is our distance x equals velocity times time. Now, the giveaway is that this is talking about the x direction. How tall is talking about the y direction. Other giveaway is there's nothing to do with acceleration in here or gravity, so that's a no-go. We can't end up using that formula, so no, don't use it. All right, so distance in the y direction, I don't know, right? That's what I'm trying to figure out, how tall. My initial velocity in the y direction, distance in the y direction, I should have said before, distance in the y direction is 0 meters per second for velocity, because I do have a velocity, but this is in the x direction, not y. My time is 1.93 seconds, and that was actually given to us. We didn't have to solve for it. It wasn't that generous. Plus 1/2, negative 9.8, again from gravity. And again, time we know is 1.93 squared. 1.93 squared plus negative 4.9 time plus 0 over here. And again, we don't even really need this part of the equation. Ends up giving us 18.25 meters. So that's how tall this guy is. It's 18.25 meters going up and down, or again in the y direction. All right, what range does the ball land at? Well, range, this means x direction. So how far out does this ball go? That's what I'm not so sure about. That's what I'm solving right here. Because this is dealing in the x direction, now I can use this formula before that we said that's a no-no. Now I'm talking about x direction, so it is a go-go. Oh geez, that is a bad one. But v is 15 meters per second in the x direction initially and throughout the entire path of travel. I don't have to deal with acceleration because gravity is not pulling me backwards or pushing me forward. It's only pulling me down, and I'm only talking about the x direction, not the down direction. Time is 1.93 seconds, again, because they were so nice and gave it to us here. So velocity times the time, 15 times 1.93 gives me 28.95 meters for my x direction. So now we no longer have to wonder. Yay. Here, how excited I am. What's the vertical velocity right before hitting the ground? Well, vertical velocity, we know that we're going to have either A or we're going to have G as part of our formula. We do have that with this formula, so we know that we can use that. Our final velocity, we're not sure, right? That's what we're looking for right before hitting the ground. That's like the split second in time, split moment in time, not even a second before it ends up hitting the ground there. So that's our initial is 0 in the vertical direction, because we do have an initial, but careful, this initial is in the x direction, not the y direction. Y direction is 0. Again, because we're only firing in the x direction. So to begin with, it is not going down, it's going out. Eventually it ends up also going down. But to begin with, it's not going down, so it is 0. Equals negative 9.8 from gravity times 1.93 from the time that they gave us. Negative 9.8 times 1.93 gives us negative 18.91 meters per second. The negative does make sense because we are traveling in the downwards direction. And I hope that was helpful.